We'll have a brief video to introduce. Good morning. Okay. So, I wanted to take you through today some what we call megacity concepts, and in particular the human possibilities around those megacity concepts. We'll give you a quick overview of the vision that we have about megacities and what they will do in the future to our lives. We'll take you through the challenges that we see in creating that vision and making it real. And we'll give you some views on solutions that we believe we as an industry need to come together and deliver. So in terms of Nokia has gone, we skipped on a little bit. Nokia has gone through a number of transitions over its history. Our vision at this point is that we'd like to expand the human possibilities of the connected world. So when we talk about that, we very much talk about the human impact of networks, the human impact in terms of what it does to your everyday life. Now, when I think about the human impact of what networks can do to your life, I don't necessarily sit there and think about a cat playing a piano with a very well-knitted jumper, or should I say sweater, because jumper's perhaps not the right word, but or a chap from South Korea doing a funny dance on a stage and being an international hit. What I'm thinking when I talk about human possibilities of the network is really things that in our overall evolution, we can change in terms of people's lives. And I think I'm going to come on a little bit later to talk about some of the challenges. And I think this is worth just thinking about, because a lot of what we do it results in entertainment or infotainment or whatever. But I think there's an awful lot of things that we do that don't necessarily get pushed forward, which do change our lives. I mean, think about this. In the next decade, what we see is that you'll actually get back 2 hours a day just from the use of technology. It's all right, my screen's gone. So now I'm going to have to turn around and, unfortunately, you're going to see I'm losing my hair. So 2 hours a day, giving back 2 hours a day. If you think about that, giving back 2 hours a day, one of the concerns I've got about that is how they're going to give you the 2 hours a day back. Because if it comes straight away, I'm all for that. But if it comes in one of those really horrible mail-in rebates, I'm not bought into that. But think about this on the serious side. 0 road fatalities. Think about what's been going on with the connected car. I think there was 1.3 million people killed on the roads in the last year. So 0 lost water distribution. I mean, anybody here from California would understand that that's a big one. If you were here from Texas about a month or two ago, you'd think that was a big one, but someone turned the tap on over top of Texas in the last month and it hasn't stopped. Healthier people. Just the issue about less transport costs, maybe reducing pollution, maybe reducing traffic jams and so on in the city. I think these are all the things that we can actually bring in terms of benefits from our technology and from moving networks forward. So what do we see? To achieve this, networks have got to become a lot denser. And what we're seeing is that, in fact, you're going to get a number of technologies that come together. And the idea is going to be to give you what you would see as infinite bandwidth, seamlessly connected across all of these different technologies. If you think about it today, what you're seeing is that on the Wi-Fi, and just think about Wi-Fi and LTE, you're seeing carriers already connecting those. You can do calling on Wi-Fi, you can go and roam straight into your LTE network. So already we're seeing a collapsing of those layers. I think what we're going to see going forward is that's just going to continue. The more layers we get, the more seamless they're going to become. So the other thing that technology does, it has the power to change what we think about objects. So if you look on the left of the screen, a car. You know, if you look at what Mercedes showed at CES and what they showed at the major car shows in the last sort of 4 months, they're redefining what a car and a connected and an autonomous vehicle will be. It's going to be, you're going to be sitting there in a movie theater. Lots of entertainment, lots of information coming into the car, and essentially trying to make you more productive. In terms of that, you know, in terms of some of these things that are driving forward, think about this, the autonomous vehicle. We're talking about cars that drive themselves around the streets. It's already happening today. I think just recently, as it says up there, an autonomous car traveled nearly 3,500 miles across the US in 9 days. So these things are starting to happen. It will affect us in terms of our behaviors. It will affect us in terms of what we do in our lives. So, well, okay. We'll skip. There'll be questions on the last 2 slides, so I hope you took notes. So, what are we talking about? We're talking about an explosion of possibilities. When you get these high bandwidth connections, there's an absolute explosion of possibilities for you, for me. We're thinking that in the next decade, there's going to be 10 times more connected devices than people. So you could end up with 100 billion connected devices in the next decade. So if you think about that, then look at some of these things, you know, augmented reality, the stuff about what people do with their lives, how much time they spend on certain tasks. I think that's all going to change for us. So now let's just take a minute and think about the challenges, because that's what technology can do. And I think if you look, even if you talk about 5G, which seems an awful long way away, in Southeast Asia, they've got a program to get 5G out before 2020. So these things are starting to come faster. They will impact us a little sooner. And what does this mean for us, and what does this mean for the carriers here in the US? Essentially what's going to happen is the complexity is going to go up. And we've got to be able to manage the complexity, because if complexity keeps going up, it's going to drive operating costs and so on up, and it's going to put pressure on the carriers. So in terms of that, you look and say, okay, you've got 1,000 times more traffic by 2020, but at the same time, a carrier needs to sit there and look and say, well, how do I make best use of the spectrum I've got? How do I try and make the best of the assets that I've got? How can I balance traffic around to ensure that the people who are really drawing down on traffic and drawing down on bandwidth get it when they need it? So lots of challenges coming, but I think the one that we should really focus on, and the one that I think is really pertinent to what's going on in this conference, is all about the complexity, because it's not just a technology complexity. It's a complexity in terms of the number of sites that you're going to end up with. It's a complexity in terms of where those sites are. When you densify down in a network, you're no longer talking about just building on top of macro sites, or building out another macro site and maybe 2 or 3 carriers come along. Now you're talking about getting into streets and looking at street furniture and trying to develop that as a site. So here's where I think the rubber hits the road. Scale and complexity of the network is increasing. It's going to increase even more when we look at densification. I think there's a number of other things that, it's incumbent upon us in terms of this industry to try and look and see how we can enable some of these things to happen. Energy efficiency, look at that. 85% of the energy is not used for revenue generation at the moment. We need to try and change things like that. If you look, global traffic's growing exponentially. The last set of data that we saw in the last 4 or 5 months said that it's speeding up. Global traffic is just continuing to rise unabated. Cloud, I don't know if anybody saw it today, but there was an announcement from Verizon about SDN and what they're going to do with their network. Cloud is going to change how networks are built, and it will impact the physical side of the infrastructure. So, if you remember, everybody told you to get your head out of the clouds. That's not such a good idea these days. Clouds are really going to impact what we do. So, about a year ago, we were sitting in a meeting in Texas, and we were looking at the forecast for small cells, for outdoor small cell deployment. And about 3 years ago, I think there was a forecast that we were going to get 750,000 outdoor small cells deployed by 2017. We sit there, what, mid-2014, and we look at it, and at that point, you look at it and say, okay, we're mid-2014, probably 2.5 years left to go. There's about 742,000 left to go. So you say to yourself, well, okay, so what happened? Why is it that we don't see this real ramp up, this scale up of the micro layer, the small cell infrastructure? And one of the things that we looked at is we said, okay, essentially technology, the small cell itself looks like it's coming. It looks like people are mastering that technology. So then it has to be something else that's stopping deployment. So we had a look at a couple of things. This is a survey that's done by Infinetics. And as you can see, this is actually a worldwide study, 21 carriers. And what you're looking at is the top sort of challenges that those carriers saw. So site acquisition, biggest challenge everyone sees. And I think it resonates with everybody who's trying to do this. Jurisdiction approval for sites, what a nightmare that is. Working with building owners or for site, power network connections, backhaul availability, another really tough one. So you look down the list, and they're all things that are in what you would call the physical layer. They're not about a technology issue, and not about whether we've created the best widget or whatever. They're all practical things in the physical layer. So what we did is We did two things. We got a particular city and we looked at 1,000 potential sites for small cells. All of the sites met the criteria in terms of adding capacity to an existing infrastructure. We looked at how much it would cost to develop each of those sites. And what you can see on the right is the histogram of how that particular study flowed out. So what you're looking at on the low, medium, high, if you look to the low, as a reference point, think of a Kia Sedona, maybe a few nice upgrades, heated leather seats, perhaps automatic windows, you name it. So the low is down around 20,000, 30,000. The high, think about a Bentley, not the convertible, but think about a Bentley with no options. What a massive sort of variation in one city about how much it can cost to actually develop a particular site. And the interesting thing is that if you take a traditional view which says, what I'm going to say is I don't want to build a site unless I can get it for less than, let's say, $30,000. If you do that, what you do to that histogram is you truncate it really close to where the low is. So the number of sites that you actually have available to you is extremely low. So first challenge I think we've all got is to create some certainty, because that distribution just leads to uncertainty about how much it's going to cost to develop and build a particular site. It leads to a pullback in terms of saying, let's go on a mass deployment, okay? I think it's one of the underlying reasons why you don't see a sort of mass rollout at the moment for small cells. So the other thing we asked ourselves is that lots of the problems appear to be to do with cities. A lot of the problems, jurisdictions, getting permits, you name it, whether someone's got a moratorium or something on antennas, on building out over ground, you name it. So what we did is we got a group out of the Ivy Business School, and we set them to look at the benefits and look at how a municipality would view dense networks. And the one thing, there's some benefits that come in terms of clearly when you have a dense network, when you have an extremely rewarding experience, when you're on your smartphone, on your tablet, on your connected device, the customer experience goes up. It also leads in terms of savings, because for the carriers, when your customer experience goes up, what we're finding is that, and your experience is consistently high, your subscriber acquisition costs and your subscriber retention costs go down. But the thing with the cities is that it was clear that we're not doing a good enough job in terms of describing the benefits of what dense networks will do to them from an economic development perspective, from the business of trying to do urban renewal, maybe bringing people back into the center of cities. So one of the things that came out of this is that, you know, unless we need to try and change cities' views about what will networks do for them, and we need to try and change their view about why they should be very cooperative about going ahead and building. And I think that particular one, if we could work on that one, it will make some of the variability that you see on the right side start to come down. As you can see, the obstacles, legal requirements, approval process, and so on and so on. I think it brought out exactly what the other study had said, but what it also brought out to us was that, you know, we need to think about an education program that says what are the benefits of these networks. And if you go back to what I said at the beginning about the human possibilities, I think that it's easier to sell to a municipality about why there's going to be a positive economic impact to them if you can describe what it's going to do for them from a business perspective. I'll go back to the original comment that I think if what you can do is you can tell them that lots more people can watch that cat play the piano, it's not going to be surprising if they don't get it, right? But if you can come along and give them a really sound view about what it's going to do to them in terms of some of the renewal, some of the attraction of businesses into their city, I think that's going to have a positive effect. And in fact, I think there are already a couple of cities here in the US that are sort of blazing a trail on that one. And maybe what we're going to see is we're going to see a couple of cities really go forward, and perhaps we'll get a really great position where you see competition between cities in terms of trying to create this dense network effect and try to attract businesses. So when we looked at it, we asked ourselves, look, what's needed to change? What would be really good to have in terms of taking a lot of this variability away and bringing some certainty? And in our mind, what really would change that is that if we could somehow come up with a value of a small cell location based on the economic impact of that location. And I don't just mean you do it once or whatever, but I mean being able to model a whole city and look at the economic impact of a whole series of cells inside a macro layer, or even as a complete underlayer as a small cell itself. So just to recap, so we looked at it and said, okay, high cost to deploy a small cell is impeding deployment. We think that's a given. The ecosystem of sites needs to be developed, and just some of the barriers that make it really tough to get those sites, we need to try and knock those barriers down. But we also need to make sure that there's an industrialized solution to deliver the high value builds. And I think, again, coming back to it, you look at all those problems that we outlined a couple of slides back about the issues that you've got on why is it small cells are having trouble being built out. And those are the things that you've got to solve. And you haven't got to just solve it on a street in a particular city. You've got to do it on a city-by-city basis. You've got to do something that will scale. So here's a typical sort of view about how you end up with a small cell and you end up with a candidate for a small cell. You start off with your candidate, you find out if you've got access to it, and if you haven't, then you have to go to the next one. And then you go back and you have a look if you've got access to it, and then you can get power back on, it fits in with where you want your RF, and you can go for construction. And I think what we're seeing is that this process can be, we can iterate this many times over. And clearly from a perspective of time, that's a really bad thing. We spend too much time just going from site to site to try and find this out. So we sat and felt that what we're looking at is really just a big data problem. A lot of the data is in the physical world, but it's a really big data problem. And we're in the era of big data. We're in the era of big data analytics. The amount of computing power that's out there at the moment is unsurpassed. So this is about a big data and a big data analytics problem. So we just hypothesized what happens if you could actually create a site value index, a value of every site in a particular location, in a street or in a district, and you could look at it and you could come up with a value that represented the economic impact that that particular cell or that particular location would have if you deployed it as a small cell there. And so our view was